This is GCSE Maths, and we're looking at simultaneous equations by the method of elimination. And so let's take a look then at a few examples and see how we get on. So our first one is 5a plus 2b equals 53, 3a minus 2b equals 19. We're trying to find our final line should say a equals and b equals. We're trying to find what a and b are. As with all of these things, the first thing I want you to do is number them 1 and 2. And then the next thing, which isn't required in this particular example, is you either need to make the a's the same value as each other or the b's the same value as each other. If we look at this one, the b's are already 2, so we don't need to change them in any way. And we need to eliminate then the b's. The idea is we make them the same and we add or subtract them and to get rid of them. Hopefully you can see that if you add these 2b plus minus 2b, then they're going to disappear. So we need to do this equation plus this equation. So that's what I've written down below. Equation 1 plus equation 2. If I add 5a and 3a, I get 8a. 2b and minus 2b, they disappear. 53 and 19, I get 72. Dividing then gives me a equals 9. So I've worked out a, now I need to work out b. So I'm going to substitute my a equals 9 back into equation 1. You can substitute it into either, but I'm going to substitute it into equation 1 because it looks a wee bit easier. There's no minuses or anything like that. So substitute into 1. 5a plus 2b is 53, that's my equation 1. I'm now going to exchange my a for a 9. 5 times 9 plus 2b is 53. 45 plus 2b is 53. 2b then is going to be 8, and b is going to be 4. At the end, it's always good, the examiner likes it if you write down a equals 9, b equals 4. A general rule for this, and I'm going to say this nearly with each question, for the letter that you're trying to get rid of, the one you're trying to eliminate, here it was the b's. If the signs are the same, you want to subtract. If the signs are different, you want to add. Let's look in this particular case. Here, the b's, they were the ones we're trying to get rid of. The signs there were different, and so signs were different, so we added the two equations. Let's move on then to example 2. C plus 7d is 20. And c plus 2d equals 5. First step as ever is number them 1 and 2. Next we want to make either the c's the same or the d's the same. Again, we've done this, they're already the same, the c's are already the same here, so there's very little then we need to do. For the ones we're trying to get rid of, that's the c's, if the signs are the same, we want to subtract. So we're going to subtract 1, take away 2. 1 take away 2. This one's nice and straightforward. C take away c gives us 0. 7d take away 2d gives us 5d. 20 take away 5 gives us 15. That gives us d equals 3. And we substitute then back in to try and work out then our c. I'm going to substitute into equation 2. It just looks a bit easier. C plus 2d is 5. I'm now going to exchange my d for a 3. C plus 2 times 3 is 5. C plus 6 equals 5. So c then is minus 1 and d is 3. Again, for the letter you're trying to get rid of, let's pull this back down again. If the signs are the same, you subtract. That's what we did here. The signs were the same as in they're both pluses, so we subtracted. Let's look at our next example. Might have ruined the surprise here, but we'll cover it up anyway. Solve these, we've got to work out what P is, we've got to work out what Q is. First step is to number them 1 and 2. We have done that. Next step is to either make the P's the same as each other or the Q's the same as each other. In the first two examples that was already done, so we didn't need to do it, but here we need to do something here. I'm going to times this second equation by 4. That's going to turn this into a 4Q, and that'll make it equal to what we need to. So equation 2 times by 4. 4 times this is 24P minus 4Q minus 68. And then I've written out equation 1. For the ones we're trying to get rid of, if the signs are the same, we subtract. If the signs are different, we add. So we're going to add these two. 29p minus 68 plus 10 gives me minus 58. Gives us p then equals minus 2. I'm going to substitute this in then to equation 1 to try and work out my q. So substituting into 1, there's 1. 5p plus 4q equals 10. I know p is minus 2, so 5 times minus 2 plus 4q equals 10. minus 10 plus 4q equals 10. This looks confusing, but it's okay. Add 10 to both sides, we get 4q is 20 and q is 5, and we know p is minus 2, so write in our answers here then at the bottom. Next example. Solve a simultaneous equation. 3a minus 2b is 1, 5a minus 3b is 3. First of all, number them 1 and 2. Next, we need to make either the a's or the b's equal to each other. I'm going to make the b's equal to each other in this particular case. So I'm going to times this one by 3 to make it up to 6. This one by 2 to make it up to 6. Times them by 3, 9a minus 6b equals 3. Times this one by 2, 10a minus 6b equals 6. For the ones we're trying to get rid of, if the signs are the same, we subtract. I'm going to do something a wee bit different here. You don't always have to do this, take away this. I can see that if I do this, take away this, it's going to give me positive numbers. Now you can still do it the other way around, it's just a little bit more complicated. So I'm going to do 2, take away 1. 10a, take away 9a, just gives me 1a. Minus 6b minus 6b, that's the same as minus 6b plus 6b, so that disappears. That was the idea. 6 take away 3 gives us 3, so we have a equals 3. Going to substitute this in into equation 1. 3a minus 2b is 1, that's our equation 1. 3 upon 3, because a was 3, take away 2b is 1. 9, take away 2b is 1. I never like it whenever the letter we're trying to work out is a minus. You can take the 9 over the other side, that's fine, you'll be able to solve it. But I like to add 2b to both sides, and subtract 1, 8 is 2b, and then b is 4. So the answer to that one then, a is 3, and b is 4. Another couple of examples then. Let's take a look. This is example 5, and it says sometimes we need to rearrange the equations. So look at this, they've given us y equals 4x minus 10 and 3x equals 19 minus 5y. There are other ways of solving these, but we're doing it by elimination, so we normally want x something, y equals something. So I've taken the 4x over to this side. I've taken away 4x from both sides, I get minus 4x plus y equals minus 10. I've then added 5y to both sides. 3x plus 5y is 19. So now we're ready to go, and I number them 1 and 2. First thing is we need to either make the x's the same or the y's the same. I've chosen the y's here. We could make the x's the same times by 3 times by 4. That would be fine. I think it's a bit less work just to do this. So I'm times an equation 1 by 5. Always writing this, by the way, so that the examiner can see what it is we're trying to do. Times it by 5, minus 20x plus 5y equals minus 50, and then write out equation 2. 3x plus 5y equals 19. For the ones we're trying to get rid of, if the signs are the same, we want to subtract. So we're going to do 2 take away 1. Again, I can see by doing that it's going to give me positives. You can do it the other way around, it should still give the same answer. 3 minus minus 20 gives me 23x. 19 minus minus 50 gives me 69. Dividing both sides then by 23 gives me x equals 3. Substitute it into one of the other equations. To be honest, I can substitute it into this one, this one, this one, this one, this one, and this one. Weirdly, in this particular case, this one's actually the easiest to substitute into, but you go into that, it'll be fine. But I'm going to substitute into y equals 4x minus 10 because I'm trying to work out the y, so it's already there for me. Y equals 4 times 3, because our x was 3, take away 10, 12 take away 10 is 2, and that's me done. X is 3 and y is 2. You may get some worded problems with these as well, so let's take a look at a couple then just before we finish. 3 times a number added to 4 times a number gives me 33. So let's take a wee look at that. That would be 3 times some sort of number plus 4 times a different number gives us 33. And the difference between the two numbers then is 4. That's a wee bit controversial, but we'll go with that for a minute. So going to look like that. I'm going to exchange my box here for an x and my circle for a y, and you'll hopefully see then where I've come up with that. 3 times a number plus 4 times a number is 33. and then the two numbers taken away from each other then give us 4. This is the hard bit. If you get this, then you're good, because the rest are just exactly the same as the 5 examples that we've just done. So let's take a wee look. I am going to, what am I going to do? I'm going to multiply this one by 3 to make the x's the same as each other. I could of course multiply it by 4, that would be fine too. Equation 2 times 3. 3x minus 3y equals 12. Equation 1, just writing it out, 3x plus 4y equals 33. This is a good example of this actually. For the ones I'm trying to get rid of, that's the x's. If the signs are the same, and the signs are the same here, I know this is a plus and a minus, but that's the y's. They aren't the ones we're trying to get rid of. This is a positive 3x, this is a positive 3x, then we're going to subtract. So if the signs are the same, we subtract. So 1 take away 2, 3x take away 3x disappears. 4 minus minus 3 gives us 7. 33 take away 12 gives us 21. And we get y equals 3. Substitute it into either of the two. You could substitute it into number 1. There's no minuses. There's an argument for that, but I think it's probably easier looking at this one. So we have y equals 3, substitute into equation 2. X take away 3 equals 4. That's what I have here. Add it to both sides, and then there's my final answer down here. One more example and we're done. Tough enough one here though, but let's see how we get on. 1,000 tickets are sold. Adult tickets cost £8.50. Children's tickets cost £4.50, and a total of 7,300 was collected. How many tickets of each kind were sold? So if there were adults and child's tickets sold and there were 1,000, that means the amount of adult tickets plus the amount of child tickets must equal 1,000. I'm going to go for A plus C equals 1,000. What's the cost of one adult ticket? That would be £8.50. What's the cost of 2? 2 times £8.50. What's the cost of 10? 10 times £8.50. So the cost of the amount of adult tickets we have is going to be 850, because I'm going to change it to pence, multiplied by the amount that we had, because that's the amount of adult tickets there were, plus 450 times by the amount of child tickets there are, gives us 73000, because I've changed everything into pence. Again, if you can come up with this, so that's going to be 850A plus 450C equals 73000. Those are the tough ones to come up with. If you can come up with those, you're in good shape. The rest of it is doable. So that's what I've done down here. That's equation 1. A plus C is 1,000. 850A plus 450C gives me 73000. This all divides down by what, 50, just to make the numbers a wee bit easier. So divide this by 50, divide this by 50, divide this by 50. If I write that, divide by 50, and divide by 50, I get 17A plus 9C is 1,460. I'm calling that in the equation 2. Here's equation 2, here's equation 1. I've numbered them, and I want to make either the A's the same or the C's the same. So I'm going to multiply this by 9. 1 by 9. 9A plus 9C gives me 9,000. For the ones we're trying to get rid of, if the signs are the same, we subtract. So I'm going to take these two away from each other. 17A take away 9A gives me 8A. 9C take away 9C gives me nothing. 14,600 take away 9,000 gives me 5,600. 8A is 5,600, divide by 8, and we get A is 700. If there were 700 adult tickets, there's not too much sums working out here. Hopefully we realise then that the child's tickets then need to be 300. This is a good one to check. So you'd want to check that this does work, and I sort of checked a wee bit earlier and it does. So £8.50 times by 700, because there were 700 adult tickets, plus £4.50 times by 300 child tickets. That does indeed give me 7,300. So my numbers do work out for us.